Hello there everyone, and welcome back to the Machine Adjustment Shack. Tonight, do your own alignment with a reasonable degree of accuracy with simple cheap crap in your own car hole. So I turned my back for 5 minutes and Johnsy's got himself a decade newer, opposite colored kind of Civic, which upon inspection looks to be in quite good shape, very well made all around, no rust anywhere or wrinkles, but the freaking wheels are crooked. First you'll want to pull your car into any spot with a flat floor that you can mark on, with the steering wheel in the perfectly straight position, as that's where you'll want it to be when you're done. That's where you want to reference the crookedness of your wheels from. So, the tools. Most importantly, your cheap laser level. And this one is nice, and it projects this crisscross pattern so that it will be usable even if you can't point it at exactly the right angle. You'll see later. Good to have some kind of a tape measure around, but I mean that goes without saying, doesn't it? Sharpie, kind of marker sort of thing, little level, various straight edges, and in this case we had to make our own straight edge, and I'll show you that in a moment. And also always handy is a set of cheap calipers for fine measurement for things like this, such as our weird straight edge. See, on a nice traditional steel wheel, a lot of them have this ridge right around here that is completely even. And there's a perfect point of reference to set the laser level right on. And this one, having the laser up a bit, will project the laser beyond the tire and everything. Just plopping it right there on the wheel. Of course, then you got these fancy aluminum alloy wheels like we're driving a freaking race car or something. So, you know, this area, that's no good. It's all over the place. There's no point of reference. So, I've got this piece of MDF-like stuff, which is pretty stable. This was cut on the table saw. I verified that it is a very uniform width, and I checked it against a metal straight edge. So, we then needed some spacers so it will rest only on the edges of the wheel, clearing the middle to be exactly parallel to it. And then, this being a precision instrument, you need exactly the same number of layers of electrical tape wrapped around these nuts here. So, I've made a center mark here between the two spacers that hit the edge of the wheel. And the first thing to do will be to get a reference mark kind of at each wheel that pretty much eliminates all the variables of crooked wheels. So we're trying to go from the center point here and get a reference mark on the floor. That being why this is in the center, and we're in the center roughly of the wheel this way. Okay, holding the laser level plumb by its plumb vial with the output of the laser beam at the vertical center of the wheel, we get a mark on the floor parallel to the length of the car. And repeat this for the other wheels. Now, with all your reference marks down, it'll be time for some serious lasering, so you'll want to load up on fog. Okay, stop. Being careful not to go overboard. Oh, Jesus. Meet back here in 30. This method only works if your front and rear track are the same width, or if you compensate for the difference. And one way to check for that and to verify that your reference marks are accurate is, once your reference marks are down there, connect the front one to the rear one with the laser line here, so that you can extend that mark, make it here beyond the wheel so you can get a tape measure across this way to the other side and check the width at the front and the back, making sure that they are the same or very close. Now, what you're usually mostly checking for, unless there's something horribly wrong with your car, which is another matter, is that the wheels are parallel to each other, going in a straight line. We have this going down the center line and pointing the laser toward the reference mark on the front. And here's where this crisscross pattern that I mentioned comes in handy. Even though this is at this height, pointing straight forward, it will project a line onto the floor that you can see in relation to the reference mark at the front wheel. Pressed squarely against each other, not rocking around anymore. You see the mark we're using there is the one closer to the wheel. That was adjusted after verification that these wheels are only pointing slightly inward at the front, especially if you take into account the great distance from where the laser begins to that reference mark. And pointing slightly in at the front is much better than out. So this rear wheel is acceptably parallel to the car, and especially since the other one reads exactly the same. And had that not been the case, every set of rear wheels has a different method of adjustment, so I'm not getting into that right now. That's not usually what the problem is. I'm more concerned most of the time that the front wheels are parallel to each other and the car, with the steering wheel in the straight ahead position. So we will now place the laser on the front wheel pointed toward the rear reference mark. And as you can see, the laser being on the inside of the reference mark on the rear wheel there, that means this front wheel is pointed outward at the front with the steering wheel in the straight ahead position, which is no good. It is fairly slight in this case, but the other wheel is doing exactly the same thing, and they need to be either parallel to each other, or if you're going to error, have them pointed the other way, facing in at the front would be better than out. So, since these wheels are facing outward at the front, and their tie rods, which do the steering, are attached at the rear, we need to lengthen the tie rods to point the wheels more inward at the front. So we need to loosen the jam nuts here. Back that out of the way a bit. Then put a wrench on the tie rod itself here. The inner tie rod, they call that, to thread it slightly out of the outer tie rod, thereby lengthening the rod as a whole. And keep track of how much you do this, and do it a few times, and you'll get good at estimating how far it needs to go. And after making your adjustments, however many times it takes, and verifying that these wheels are parallel to the car by their laser landing on their opposite reference marks, you can tighten those jam nuts down and drive on. And there is all that an alignment usually needs to be. In fact, I can't recall doing anything beyond that in many years now. I have not been to an alignment shop. I've been using that method, and all of our incredibly old vehicles go perfectly straight down the road and wear the tires evenly. But of course it can get more involved if there are other problems with the car. There has been damage of some kind, but especially the geometrically inclined of you folks will immediately see how these methods can be applied in other directions and to greater extremes, taking further measurements and referencing other things. So thanks for watching. I hope that was helpful. I'm happy to answer any questions you may have about the matter if you leave them in the comments below. If you like this sort of thing, any kind of interaction with the channel that you do is helpful to me. click the like button or the dislike button. Subscribe if you'd like to keep watching this sort of thing. Or even leave suggestions of what you'd like to see. So see you next time.